Hello everyone, welcome back to Advent of Code. We're going to do day 5 today of 2023, of course. And for a change, I don't have anything to say about any updates made to yesterday's solution. It was just perfect first time, so no updates there. Let's just move on to day 5. Day 5. If you give a seed a fertilizer, this is like if you give a mouse a cookie kind of joke. You take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source? Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days. Weeks? Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry landing soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? I like this. It seems like we're going to be solving the problem depth first, right? X isn't working, investigate X. You know why X isn't working? It's because Y isn't working. And Y isn't working because Z isn't working. And we're going to spend, I guess, the first half of the Advent tracing down the root cause of something and then revisit all these islands on the way back to adjust for, I don't know. Anyway, that would be interesting. You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived, and we're having trouble making sense of it. The almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Goodness. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. Okay. So it lists all of the seeds. I don't understand. Okay, I'm going to have to read further to understand what this map means. Because I don't see any numbers of seeds in this seed to soil map. But it looks like we have seed to soil to fertilizer to water to light to temperature to humidity to location. Fine. The almanac starts by listing which seeds need to be planted. 79, 14, 55, and 13. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. That is, the section that starts with seed to soil map describes how to convert a seed number into a soil number. Okay, so okay, weird, but fine. So how does it describe this? Rather than list every source number and its corresponding destination number one by one, great, the maps describe entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. I see. So this means destination range start is 50, so it'll be 50 in soils, right? And there'll be 2 of them, 50 and 51. Yeah. And so, as it's saying here, seed 98 corresponds to soil 50, and seed 99 corresponds to soil 51. Okay. And if the source number isn't mapped, then just pass it through unchanged. So if we were mapping just 50, well, kind of from 98 to 50, really, right? And from Okay, wait, what? So... Huh. Okay, fine. This map, you can look up the soil number required for each initial seed number. They want to get started, they look to the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. What? Okay. So, I assume the number of seeds we have is relatively small. And we can pretty much just, like, for each seed, burrow our way through however many levels of translation. And then, like, get a location for each and find the one with the lowest location, and then, like, that's our answer. Right? But what is part 2 going to ask of us? I don't know. Okay, fine. So there is one little change to my development setup here. We'll see if it's worth the screen space. But I complained in a recent, I guess the last episode, that I tried to update my Emacs Haskell integration, and it was just a nightmare, the same as it always is. And I got nowhere. And someone said, sure, but you can at least get something by having GHCID running. And that's fair enough. Maybe it would just be enough to tell me, like, oh, what you wrote doesn't type check, right? Like, I get instant feedback in here that, like, something is wrong. I don't have a ton of space here to read the text of the error, but, you know, I can scroll if I have to. And importantly, this gets updated every time I save the file and is in the same tab. Well, not tab, but tmux window. Yes. This is a separate pane in the same tmux window. You can never remember how all the wording for all this stuff, right? Like, Emacs is so old it predates the name of window, meaning what a window does now. And so it refers to, like, the window that holds the Emacs program as a frame. And the stuff within it is windows. And there's also buffers, which, anyway, doesn't matter. So the point is, now I'll be getting feedback when I save about whether my file compiles. And that hopefully will alert me a little bit sooner when I'm making some blunder. And I won't have to tab over to GHCI to test if it compiles. So let's start. We're in day 5, right? That's the file that I'm editing. Can I... Yep. Actually, let's go get my input first. And have a look at it. Okay. Oh, big numbers. But there's only, like, I don't know. How many spaces are there? Like 20 seeds? Very, very long ranges, though, huh? Or, like, the numbers are big. They're not like 10, right? They're a few million. I imagine okay, it is the same like set of transformations ending with humidity, for example, or humidity to location, for example. So I guess we want a concept of a map, which we're going to implement with a Haskell map, but we want a separate concept for like a seed map, right? We could risk just calling that map and referring to the other one as m.map. That strikes me as a little bit confusion prone. Now, what is the algorithm we will be using? I mean, that depends a little bit on our data structure, but the two inform each other, right? So we should think about both. The obvious thing to me is to actually have like 7 maps or whatever it is, however many there are, where what am I saying? Where we are going to bring a seed number, and we want, or a number of some kind at the top level, a seed. And we want to know, what does that map to? When we're given this map, how will we search it? I think this map should be, of course, keyed by okay, sorry. I lost track of the sentence I was in the middle of, because one of the nice things about recording for YouTube instead of streaming is I can just like cut the recording if I have to go sneeze. So that's what I did, and I'm back. I was talking, I think, about the algorithm for like searching here, and we want this map, of course, to be keyed by seed, not by soil, even though annoyingly they've put the soil mapping first, and I forget whether this is the range. I think this is the destination and this is the range. Let me check. Yeah, the last one is the range, or the range size, or the range length, or whatever they were calling it. So we have a seed. We want to look it up in this map. We could, of course, just have like a list of all the mappings that are being made, and then like scan through the list, and then as long as it's sorted, we would, well, first of all, I guess we could find, even if it weren't sorted, we could find, what is the largest one that is still smaller than our entry, and does it, or I mean, we could just check all of them and say, I have a range that's X long starting at Y. Is S the number I'm looking for in that range or not? And keep going until you find one that is. But by sorting, we can do like a binary search approach, where we quickly find, what is the range closest to this one, closest to the number we're looking up, and then say, like, does it include the one we're looking at? Does it include the seed we're trying to map or not? And if it does, then we'll use the map, and if not, then we'll just use the original seed to look at the next step. So Haskell's data map, I assume, has where's my data map documentation? Here it is. I assume has a way to say, like, find smallest key larger than, or something like this. Query submap index? No. Query? Look up find default member. Look up less than, yeah. So find I would want the largest key smaller than the given one. And it would tell me, oh, here's the key value pair. And we know that there can only be one mapping for a given number. And that one will have to be the largest mapping whose start is smaller than the key or the value we're trying to find, right? Because if there were a bigger one, they would have to overlap. So just putting them into a map sorted in this way, we can use lookup LT to find exactly the one entry we care about and see if it's there or not. And, you know, it's log n because data map will do the binary search for us. In a map of size like 10, the binary search is not going to be super important, but it's the principle of the thing, right? I think ideally, like, what do I write advent of code programs for? I certainly don't write them to get on the leaderboards, as you will surely have figured out by now at this point in the video, since I haven't written a single line of code. I write it for a few things. Sometimes, you know, I've used it as an opportunity to learn something new. Like, you know, Advent of Code 2015, I think, was most of how I taught myself, like, to actually write some Haskell programs. It's fun to share stuff with the audience, you know, and that and help people out. I enjoy getting, you know, the thanks, I'm learning Haskell and this has been very helpful, stuff like that, right? You know, it's nice to just, like, get to play around with coding, but, like, it's also, you know, what kinds of programs do I try to write? I guess we might ask. Nope, not here. And, like, on the one hand, you could look... Oh, no, get out of here. You could look at my day one solution. And... No, what? I don't know what's going on with my HLS. When I tried to update stuff, it got worse. Like, this is not the most beautiful or readable code, for example, right? And it's not the shortest either. It's just a style I kind of enjoy. So sometimes I try to write, like, clear code. Sometimes I'm trying to write, you know, fun code. Sometimes I want to try out some new thing. But I think a lot of the time, what I want is, like, flexible code. Code that, you know, they're giving us a map of size 20. What if they gave us a map of size 2 million? It would be nice to have a program that still works in that case, right? Figure out an asymptotically good solution. Try not to depend too much on specific details in the input, right? Something that would work if you just read the problem statement and never looked with your eyes at an input file, so you don't know exactly how big anything is or whatever. You're just flexible and fast. You know, I'm not trying for the most optimal solution, but just like something that would work for any conceivable input, not just the ones that Eric happens to give us. That's one of the things I like. And so, like, using a map to do a log n lookup versus linear lookup is important to me, even though it's not the way to do things fastest. So, I don't know. A long digression. Just sort of wanted to talk about that, I guess. No. What's modified in that buffer? Nothing. Okay, great. So, we need a few imports here, obviously. Same ones we always need. Why am I importing control? I don't want that. Text regex, applicative, re, sim, string. Probably don't need psim, right? Well, actually. What's in text regex applicative common? Does this have... I don't want to look at that. Contents. Does this have, like, No. Common is basically just numbers. Okay. So we'll have to use a piece to match, like, non-dashes, for example. We'll have to use psim and data. No, we don't need to use data.char to match non-dashes. We can just say not equal to dash, basically. Yeah, okay. Yeah, and then of course, as always, the way to match stuff. And heck, we still need numbers again. Decimals. Right? The input is just it's a decimal. Okay. Yeah, the import is redundant, but I don't really care. And it looks like there's never multiple spaces in between numbers, so we could actually just use a single space. Okay. So import data.intmap, I guess. Because that should have all the same functions, right? GT. Yeah, lookup GT still exists in intmap. And our keys are going to be ints, so we might as well have an efficient map instead of the one that is like generic. Let's define a... we could just call it a map, which, as I said, would be a little bit dangerous. What if I called it a horticulture? Let's call it a rule, right? Well, but the maps, each mapping is kind of a rule inside of a map. I don't want to jinx myself by naming something map and then being confused about it later. We'll call it a mapping. Is a mapping of the annoying thing is these are kind of like never gonna exist. But I have this idea that it's like from and to are are both strings. And then ranges are like a list of pair or triples, I guess, a range. Where like data range is a range of source dest size all ints. So like this is something we could write, but these mapping objects are not going to exist, is what bothers me. Like if I ever create one of these, I'm going to throw it away immediately. Because what I actually want is a map instead of this range, this list of ranges. I want to compile that as soon as I get it. And then the from and to, I don't need those. Well... Because I want like a top level map that the whole program has access to, named like where like a key is seed and the value is like soil, basically. or it's something like that. Even though, like, if you look at the input, the first map that we have to go through is like for seeds, and the next one is for soils, and the one after that is for fertilizers, and then that's a long one. And then for water, like, so each one of them, you have to look at the next map immediately. We never have to like jump around. But again, the problem statement doesn't promise us that, right? They could put the water to light map first if they wanted to, according to the problem statement. And so what I want is to like say, okay, I'm processing a seed. I need to look in the global map of like lookup of mappings. Where's the one labeled seed? What are the ranges it specifies, and what other map does it say to look up next? Like, okay, I've translated into space, into the destination space. Is the destination space fertilizers or soils or what? Sorry, you guys. There you go. I switched back the windows a second ago. So like this all, I don't know. I guess it's fine. I'll have the parser produce a list of mappings. I don't think we really need eq or ord or anything for mapping or for range. We'll just parse a list of mappings from the input. And then we'll have another function that turns a list of mapping into like an efficient set of data structures, I guess. Which doesn't seem that complicated, does it? We could actually call this a page, like this is a page in the atlas. And then I have the word mapping available for the efficient, for as like a type alias for the int map I want to use or something like that. So like, let's define a type for strings that are, you know, ingredient. So we're just going to define a new type called ingredient, and it's just a string with a fancy name, but it's to clarify what these strings are for. They're not just arbitrary text. They're things that you can put in the ground or whatever, or that you need to plant something. And that way we won't get them mixed up with other strings, hopefully. So what's the type of our input, I guess, is kind of interesting, right? So I want like a mapping to exist that's just the efficient storage of these ranges, right? It's an m.map of, well, not pairs of ints. Let's define data. I already have a range. I mean, like, really all I need is the destination and the size, right? Because like, I'll have the key from, it'll be the key in the map itself, but I'll store the source itself redundantly in the range, I guess. So it turns out these do need, wait, no. Doesn't import, doesn't export. Is it int map? Oh, okay. So an int map of ranges is like a function that can efficiently. So okay, let's write a function that we know will be useful now, shall we? Translate takes a mapping. I think this is the best order to take these arguments. And an int, and returns another int. Translate of source is case. Lookup GT should give me a maybe, right? I assume? Yes. So I can actually, I don't need to use case. I can use maybe? Maybe source or. So I'm going to look up something. Fmap. Go. As always, when you don't know what to name a function, go can't be too far wrong. Fmap go over m.lookup lt takes the key and then the map source. Oops, m. Oh, this is accidentally indented. Where go. We know at this point we will definitely have a key, which we're ignoring, I guess. And a range from, no, source dest size. Do I want to guard here, or can I just do some? Yeah, I guess I do need to check whether it matches. I can't like do some unconditional arithmetic here, I don't think. If source plus size is greater than only if it's greater than, right? Not if it's greater than or equal to. Because if it said like we map 50 of size 1, that would be mapping only the number 50, not the number 51. So if they're equal, this shouldn't match. If source plus size is greater than, oh, let's call this Q for query, shall we? Then source plus size was so query is within the range. So we need to produce destination plus the query minus the source, right? Because that's the offset from the source and should therefore also be the offset from the destination. Yeah, that seems right. Otherwise is just Q. So I think that makes sense. Couldn't match type. Well, it doesn't even type check. Dollars applied. Oh, yeah, that's true. Do I just want maybe Q go? Yeah, that makes sense. Because this returns a maybe. If it's nothing, we want Q, and if it's just, we want to unwrap the just and apply go to it. Yes, that makes sense. So we'll do it the stylish way here. Look up LTQ. Ooh. Oh, it's so tempting to flip the order of these, isn't it? It would make the... I could then eliminate the M argument. But I don't think I should. I think that this is the signature that makes the most sense outside the function. Inside the function, it's no big difference, really. So... maybe I'll be wrong, but I try to write APIs that look like they'll be useful to be partially applied, and I imagine this would be the one that you would partially apply more often. I don't know. So I'd like to test this function already. Do we have good examples from the problem? Yeah, I mean, there's some pretty simple ones here. Seed to soil map takes very few things, right? We can build that by hand, I think. So, reload. What am I making exactly? I need a mapping, which is an int map. Let m equal, or let seed to soil is m dot from list of, and there's just two entries in here. Which one is first again? The destination range start is first, but in my range thing, it's source first. So I want 98, then 50, then 2, and then 50, 52, 48. You know what? Let's just couldn't match type. Oh, that's true. That's completely wrong. So from 98, we get a range of 98, 50, and 2. And then from 50, get a range 50, 52, 48. Is that better? Yes. Seed to soil is an in-map of range. So if I then ask, translate, what's an example? Seed number 98. Sure, that's an interesting one. Translate seed to soil 98. It says 98. That doesn't seem right. Did I make a boo-boo? Because that should be getting mapped to 50, for sure, right? At 98, we have a range that starts at 98. Oh, wait a minute. Look up LT, giving the first one that's smaller. I want LE, not LT. Look up less than or equal to. It's a good thing I tested this case right away. That could have been unpleasant. Now it says 50. Great. Say 99. Should be the same. Or also mapped down. And then when I say 100, we should get back 100. Great. Works a treat. And if I go down to say... Well, even if I go down to just 1 to 97, this one, the second one should start applying, right? It should be adding 2 and we get 99? Yes. Okay, so this all looks pretty good. Where am I? I'm lost. Okay. So translate is basically the only math we have to do today. The rest is all parsing and a little bit of pointer chasing through maps. So, okay, let's... A parser for A's is an RE of char and A, as always. What is the simple... I mean, there's also, you know... We want to process this file. And you can start, as I usually do, kind of bottom up. Define parsers you know will be useful, like a parser for an int. Well, okay, that one's imported, but like for a line or something, a range. And then build a parser for mappings out of that. And that's fine. You can also do things top down. Just define like the parser for the file, delegate to functions that don't exist yet, and then write those functions. I don't know. Let's, as I guess I usually do, let's start bottom up here. Let's define a parser for, I think a range is easy enough, right? Data range, nope, not data. Range is a function, is a parser for range. Range is, I wonder with this, yeah, the window, I mean, it's pretty narrow if I'm making space for the GHCID at the bottom, but it's good enough, I guess. I can still fit 2 things on screen. I do everything in one terminal window with no mouse, sort of as a self-imposed challenge. A few years ago, I was like trying to get the hang of using tmux regularly because I got sick of having, you know, open 25 different console tabs that I lost track of what they were all doing. And also it's means I don't have to manage multiple windows for the recording. But it is sometimes challenging when I have such tiny amounts of screen real estate. Anyway, so the range is, we're just going to parse 3 ints, basically, right? Except we need to flip them, kind of. A little bit. We'll call it go. It'll be great. Go of decimal. Sim space decimal sim space decimal. I don't where, yeah, you're right. Go of dest source size is range of source dest size. So like, I don't know. I guess go is just flip range. Yeah, okay, let's just do that. Flip range. Is that true? That's kind of an important thing to not mess up. Destination range is the second, length is third. Yes, this seems right. Now, I'm always nervous about mixing this operator and this operator, like, because I don't know their parse precedence, and sometimes stuff is just wrong. But here, the types couldn't possibly match if something were wrong, so it must be right. Okay, and what is a mapping? A mapping is an int map to range. Okay, so we can do that then. Mapping is... Yeah, I guess we can just parse this, right? I guess I need control applicative, import control applicative sum again. It's m dot from list, but before you call that, you have to map from range, I guess, and fmap all that over some right, we're not handling the lines separately now. We're parsing the whole thing all in one go. Some... how many lines? Well... Yeah, I guess we'll consume this new line at the end here. So it's... range... Is there one at the end? There is. Okay. Sim new line. Right? Where from range of range dest, nope, source dest len as r is source r, basically. I guess we can do that. Okay, that actually compiled. That's nice to know. It could still be wrong, but it compiled. And now we need a parser for pages, I think, right? Which I think is simple enough. Page is a parser for page. Page is do. I think there's going to be enough things here that I'm going to have trouble if I try to do it all in applicative style. Source ingredient, ignore a hyphen, actually ignore something to something. Dest is another ingredient. Ignore the word map colon new line. And then read a mapping, right? Now I want pure of, what is a page? How could anybody keep this shit straight? Page of from to and then the ranges. Oh, well, I guess I'm never actually using this, huh? Mapping. There you go. Doing all this in the parser. Be a little embarrassing if it turns out part 2 is like, no, you didn't understand what the rows meant, wouldn't it? Well, we'll cross that bridge if we come to it. Probably won't. Maybe will, though. Well. Oh well. Pure of page from to source dest and then mapping, right? Ingredient isn't defined, that's true. Where ingredient is just some psim of that are not equal to hyphen, basically, right? Okay, that type checks as well. Nice. Now our input is basically just like parse the seeds and then a bunch of pages, right? So I think we're actually going to throw out our input type alias for a change and say I have a data input. Well, no, I always like having a type alias for input. Data almanac, I guess is what they called it. This should go somewhere else, this data definition, but we'll leave it here for the moment. Data almanac is a list of int for the seeds, I guess. Because we don't have a word or a type yet for ints that are meant to be ingredient numbers, right? We have one for strings that are meant to be ingredients. Ingredient names. All right, well, whatever. We'll just say int. It's an almanac of first a list of int and then a list of pages. Right? I think that's all it is. That makes sense. We already have a parser for page. So now I just need almanac is a parser for the whole thing. Almanac is almanac mapped over seeds, I guess, and some page. Where seeds is string seed, seeds colon space. We'll not include the space. Ignore that and then parse some sim space decimal. And then parse, but ignore string new line, I think, to get us lined up to here where we want to be. It still compiles, so it's possible. Definitely want show on that. So what if I were to try actually doing that? and say equal almanac of seeds 5, new line, seed 2, soil map, new line, one, two, three, new line. And that's the whole file. It parses. Great. An almanac. Yeah. So that makes sense. What if I just said input is read file input.txt? Did I get the file? Yes, okay. And then I said equal tilde almanac of the input. Yeah, that parses. Great. You know, is it correct? Well, we can't say that. Maybe I have some mistake in my parser that flips some numbers around somewhere. But it looks pretty plausible, right? And it wasn't nothing. It was something. The whole string. That's one thing I like, I don't know, about writing a parser instead of some regex scanner thing. Is like you're more in the mind. Okay, technically what I'm writing is a regex, but it's like the good kind. You're more in the mind of like actually ascribing meaning to every character in the file. And when you use a regex, you're just like trying to scrape garbage off the walls to like find meaning in some nonsense. I don't know. That happens when people use like regex find, you know, here's a giant string, find me something that looks sort of like a person's name or whatever, right? You can certainly write regexes in a way that you carefully match every character in the file, but often people don't. Here, since I'm using equal tilde, I'm saying like the entire input string must match this regex. And if it doesn't, I'm going to get nothing. Here I got something. So I'm reasonably confident I have described to Haskell how to understand the input file. So let's celebrate here. Day 5. I forgot what day it is. I had to like look at the this thing to tell me what day we're on. Okay, it's committed. I can't fuck it up anymore. Oh, except hang on. Wasn't I supposed to be making a mapping out of this? How did I end up with a range? Oh, right. My mappings contain ranges. The key is one of the numbers in the range, and then we contain the whole range, even though we don't need the entire number anymore. Sure. So that's all fine. I can close this. And our input is an almanac now. Prepare is, you know, from maybe, I'm gonna have to import. Need a maybe from maybe error, saying if it fails to parse, just blow up, please. From maybe error equal tilde almanac, right? Error is applied to too few arguments. Oh. Cool. Yes, you're correct. I was thinking that from maybe would somehow call the error function with the results of failing to parse, but the only thing it has is nothing. What could it pass? Nothing? Not very helpful. So, great. Now we've parsed everything. Let me move that type that I said was in the wrong place. Something like that? I don't know. We define a range, then a mapping is based on a range, a page is based on a mapping, and an almanac is based on a page. Makes sense to me. Kind of hate this name ingredient, but I'm stuck with it now. I wrote it down on paper, chiseled it in stone. So but no, this is not quite right. I don't want a list of pages. I want a map of pages keyed by their source. So I can say, you know, flip the index and then flip to the page for seeds or whatever, right? Conceptually. So this is almost right. So our page is a great data type, but it's not what our almanac should store. In the same way that, like, okay, yeah, this range has all the data we need, but we want it sorted by source, so we put it into a map. Our page has all the data we need, but we want it sorted by from, so we should put that in a map. But this is a map from string. Oh no. Can you, now if you import two different things... Okay, let's replace m dot with im dot. Okay, great. So this is an IM and data map strict as M. What could go wrong, right? So I want not a list of page, but an m.map from ingredient to page. And now it doesn't type check because my parser for almanacs is wrong. Of course. Not collage, collate. Hello, I can't type? Some pages, yeah, so we can just write a little collate function here. Collate of pages is m.fromList of source and E entry for page source ignore in pages. Compiles. How could it be wrong? Our almanac needs to be showed, doesn't it? Is it already? I guess it is, okay. So let's check real quick that I haven't somehow ruined things. I shouldn't have, because I didn't modify the parsing code at all, only sort of the post-processing code. Let's just do that again. Yeah, that seems fine. And now we can see here's a function, seed to soil. Look at that. We've got our list of ranges. It starts at 0. Great. So we kind of now want a function that is like multi-translate, right? That takes a seed as input and churns through every page in the index until it gets out a final number. Right? That makes sense. Solve, in a way? Like, or location for... Just call it location. Is function from int... no. Almanac first would be a more reasonable order. Because we're going to want to apply this function on a single almanac and many seeds. So we should map over applying to the almanac, basically. Almanac and int to int, basically. Location a seed is... I don't want a. I mean, really, what it needs is this. Okay. Type index is this. It doesn't have to make sense. It just has to... What do you mean? Oh, I didn't finish writing the stuff down here. Sure. I don't need the almanac, really. I just need an index. So the location of index seed. Location based on the index is go of seed, I guess. Where we're going to actually write a recursive function. It's not our first in Advent of Code this year, but it's got to be close, right? So much of the recursion is farmed out to existing libraries. It's sort of bad style to write manual recursion unless you have a reason, right? There are better tools available. It might be interesting to go back through the previous days and just ask myself how much recursion has there been. So, fine. Go of seed, where go of ingredient and n is the number that we're looking up, is case, I guess. Well, I guess it's just maybe n or something. Because I'm going to need to call some function, like look up in the map. Handle, I don't know. Of m dot... Is it called lookup? Is that how you get something and then see if it's there? Or get a nothing? It is lookup. M dot lookup ingredient index. And handle is undefined. Is this type check? Yes. Okay, good. So handle will be called if we successfully looked up a page in the index, right? Handle is a function from page to what do I mean, to int, kind of? Is that right? It is. How has it managed to have that type? Where did the n I was working with go? I guess the answer is it needs to be in the closure, right? So I need to say where. There. So now I can just refer to n because I closed over it. And it will delegate itself to go once it's done handling something, I guess. So what's in a page is a page from to ranges. And what do I have? I had something that looks things up in a mapping? Yeah. Translate. Looks things up in a mapping. Okay. What am I? Why can't I find my previous location? Okay, we're calling it location, I guess. Handle of page from to, right? Mapping, M? No. I guess mapping, even though it's going to shadow the local and HLint will be mad at me. Is go of 2 and translate the mapping of n. It type checks. Huh? That's kind of cool. What are the other things it's complaining about here? From is defined but not used. Oh, well, I mean, that's fair enough, I guess. I'm not using this. Mapping shadows. I know. We'll call it next. There. And normally I wouldn't bother giving a type signature to handle there. I just wanted to check that it was inferring what I hoped it would infer. So now I think like part 1 is about ready, isn't it? Part 1 of, I guess we'll name this argument of an almanac of seeds and pages is, you want the smallest number, the largest number? Lowest location can correspond to any of the initial seeds. So it's minimum.map they're not actually pages, are they? It's the index. Where am I? Location index of seeds. It also type checks. Let's see what happens if we run it. It's a number. We could see if it's the right number, I guess. No, too low. Okay, well, fair enough. We were doing too well today. Something had to go wrong. Problem is, too low doesn't tell me that much. right? I need to figure out what went wrong. First of all, I guess we can go look at the input. Where does the number I entered show up? Anywhere? I imagine there's got to be, by the way, some way to use tmux to copy and paste in between different buffers or Windows and Tmax. I'm just using like the Windows terminal, which sucks to do that, but okay. So yeah, that string never appears, which makes sense. That's about what I thought would be the case, but if it did appear as like the first seed, we would be like, that looks like a mistake. How big is this number? Our number is 8 digits long. That's pretty low. Well, no, I guess these numbers are like, yeah, I mean, these are 9 or 10 digit numbers. So being 8 digits is in the bottom 1 percentile. If we were looking for something that's low, that's possible. Although, yeah, I don't know. A little unlikely, right? Because there's only 20 or something numbers. Getting one in the bottom 1% is not super likely. So is there a smaller input we could test on? I mean, there's this. Yeah, okay. So let's see. Input.real. Oh, you guys can't see that. I was just moving my input files around. So I can write the test input. There you are. Input.text looks fine. If I now say stack run, I get 13. Is that what I should get? No. It says the lowest location number is 35. So that's good. We can reproduce our problem on a small input. Something I'd like to do, actually, is to hack up the input format a little bit. How can I do that? I want to be able to edit this and just like put a hash here. And that means don't read any further. That's the end of the file. And that way I can say, does it make it correctly through this first translation step? And if it does, I can move the hash down here and see, does it make it correctly through this next one? And so on. And I think that's not too large a change to the parser, right? We just need to change the parser for almanacs so that it optionally ends with how do you say optional? 0 or more? Like maybe? Try? No. All right, it's off to look in control.applicative today. Should be something under alternative, right? Some, many, empty. No. Optional, there it is. 1 or none. Okay. So we want to match an optional of sim hash followed by many any sim. We actually have to import any sim for a change. Any sim. Doesn't type check. Oh, optional is here. Many is here. Okay. So now what would happen if I said input is this? I have a file. I have a binding name. Oh, I have to reload. Now we have an almanac. But it parsed all this shit I said it was supposed to stop at. Oh, wait, no. I think I just didn't actually leave the hash in. So that successfully parses the real format. If I put a hash here... Uh-oh. I see a hash in the input. \n soil. Yeah, so it found a way to match the whole file, treating hash \n as the name of a thing. Okay, a little too creative, I guess. So I think I just want is alpha from data char somewhere. Do I not have data char today? And when I'm saying, where's my mapping for ingredients? Parser for ranges, for mappings. An ingredient is some psim of is alpha. I could avoid having to write 2 lines every time. Almanac. There we go, that's better. Now it just parsed seed to soil. And that means we can say stack run, and it'll tell us what it thinks it should get out of the first mapping, 13. I think that's already wrong. So I copied this. And it should have been 10. No. Well, 13 is actually correct here. You know what would be better? Is if I edited part 1 a little bit. Instead of outputting the minimum, it should just output like all of them, and it should be a list of pair of int and int. And like this is the real answer. But I'll have it for now be do seed from seeds, location seed, pure of seed lock, right? So it'll tell me where every one of them's going. What's wrong with you? Location is applied to too few arguments. Ah, right. Location index seed. Great. So now if I stack run, we can see where it decided to put all of them. 13, 14, 57, 81. Well, in a different order. 79 to 81. 14 to 14. 55 to 57. 13 to 13. That is correct. That is what this says our map should do. Okay. So if I move this hash down here, you know what, let's, oh, sorry, you can't see. If I move the hash right down to before this last mapping, is it correct? And something goes wrong at the end of the list somehow? I'm guessing not, but maybe. Stack run again. No parse. How come it parses when I put it here? It doesn't. Why did it parse when I put it here then? These look the same. What? Oh, the hash has to go somewhere different, doesn't it? Maybe? Because my parsing format is very, very specific about where new lines are. It is not flexible at all. So seeds is seeds 2 new lines, and each page starts at exactly a page. Like this is where the page would start, right? But that's not gonna. Ingredient to something map. And then we parse a mapping. A mapping is a range followed by a new line. And a range doesn't end with a new line, right? Yeah, it ends with the decimal. So decimal here. New line ending the range. No, the range is already over. The new line is ending the whole mapping. And that ends a whole page. And to parse a page, some page. So a page starts at the beginning of a line, I think. I don't know. If I do this, does it work for some reason? I don't understand. No. Oh, come on. I had just gotten my cool, like, putting a hash thing in to work. so that it would go part way. And it only works here? In between the first two? Why? There it's like, yeah, that's a parse. And here it probably doesn't, right? Yeah. Likewise here, for sure it does not parse there. Any of these parse? Why would one of them not, is what I want to know. Oh, you know what? I think I understand what happened. The problem is, well, no, hang on. I'm saying after you parse some pages, there may be some extra garbage at the end. And I thought maybe, like, this was only triggering after exactly the first page. But I'm parsing some pages. And the only way that should fit, I mean... we could certainly try writing this so that after every parse error on input where? Oh, did I... What? Oh, I didn't... I added new parenthesis. Okay. Yeah, of course. I don't know what the fuck I'm doing. Does it still work if I put it here, or did I break even that? That still works. I have no idea why. Okay, well, I mean... This was just supposed to be a quicker hack than editing the input file by hand, and it clearly is not. So... I'm just going to say some page again. Man, I was using... That was way more... I got deeper in that than I needed to. Okay, so fine. So if I just like delete that and save, I can then just put it back. I should have a smaller input file and it'll tell me where we got to. No parse? Still no parse. Oh god, what have I done? I didn't leave in any hashes. Okay, I mean the parser's all different, but like not in important ways, I think. psim is alpha seems fine. Collate some page, that makes sense. This is what I get for not committing before I start hacking something up, I guess. So all the stuff down here about location and part 1, that can't be the problem. Because it's not related to parsing. I see we made this change to ingredient, where psim is alpha instead of psim not equal dash. But I think that's fine. And arguably better anyway. We're mapping from range over... Yeah, the only difference is which kind of map we're putting it into. Oh no, I mean, there's no difference. The parser is the same. Did I mess something up in my manual editing? Okay, I guess that's a possibility. A strong possibility. Maybe I typed a Q into this file by accident or something while trying to give Emacs a command. So maybe what we should do is move input.text to input.sample. Although before doing that, okay, make sure it's the whole file. Input.real, input.text. Stack run. No parse, right? Of course. So I really did break the parser somehow. Okay. Well, time to go back to the REPL, I guess. Equal tilde, I mean, let's just look at some of our earlier equal tildes. So this will say nothing, right? Yeah, okay, great. But I had some other stuff where I used equal tilde before. So like, does this parse? Yes. Soil, oh, we need another new line here. Soil to food map. And 2, 3, 4, new line. Now, so that's nothing. But I think that's right, isn't it? That's what it's supposed to look like. There should be 2 new lines after the last number in the first mappings, which is this 3 here. And then we should have a blah 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 map colon new line number number number, and then one more new line. Yeah. So that this is a valid input that we fail to parse in our brand new world, sadly. Why? What if it equal tilde some page on, oops. Pages start like this, right? So shouldn't that doesn't match, but that does. Why? Did I delete the new line when I was editing? Oh, I bet I did. Like, page. Well, I don't know. How a page, like, was it like this? Page new line or something? course not, right? Yeah, of course not. Well, okay, I guess we can do a little more experimenting here, where we've got the problem kind of a semi-minimal reproducible case. Where does it want more new lines or fewer new lines somewhere? Yes. The new line in between pages somehow got lost. So this is an incorrect input that it parses. Oh, you know what? I wonder if it actually is the change. Was I wrong all along and just like got there by accident? This happens a lot in software. Where am I? Is alpha. So when this was not equal hyphen, was it matching new lines? Accidentally? It was. Oh, man. And it just happened to work because if we go now to here, look, we have seed is the first one, and it doesn't have extra new lines because it's at the beginning of the file, and it's the only one we hard-coded the name of. We give the string literal seed, right? And then the others all have new lines in them. The only way to make things parse was for the name of the map to have a new line in it. But oh, and that's why we get the wrong number. Because we have a map from we have a map from seed to soil. And then we say, is there anywhere here a map that maps soil to something? Oh, no, there's not. All we have is \n soil. So I thought I was being nice and cool in general, and I was, but it was masking a problem in my parser. There's a new line I forgot to account for in the format, and it snuck in somewhere I didn't intend it. And so we only go from seed to soil, and then we stop. We give the right soil number, but nothing else. The others, yeah, we just stop there, right? So shouldn't a page then... A page should start with a new line, I think. And the list of seeds should only consume one of its new lines. And now we have a map from seed to soil, and then a map from soil to food in my example. And it parses the right list. Okay. So let's just try stack run here, because I have a new program that I have reason to believe might not be ass. Okay, well, I mean, I have no idea if those numbers are right. So let's move input.text to input.real. And input. I forgot what the other one's called. Sample to text. And see if we get the right answer for the sample. Those numbers look familiar. Let's see. 79 goes to 82. 14 goes to 43. 55 goes to 86. And 13 goes to 35. That's exactly what our program produced. So, if we come back here, what happens if I do that? Oh, it just works. Great. And then stack run again. We get a big garbled mess of numbers because I'm still using the diagnostic version of part 1. But if I were to comment this out and that back in, yes, true. Stack run. It's a number. And it's much bigger than my last one, which is promising, because that one was too small. Okay. Got screwed by parsing today. Well, you know, I deserve it. So let's get ready to commit this. Throw this shit away. Import data chart. Okay, we no longer have any warnings. I could turn on warn all and stuff, but I don't know. I'm a cowboy. You can't make me. This type kind of belongs up here, doesn't it? Higher? Sure. Yeah, I don't know. I guess this seems fine. Oh, yeah, what a sneaky little bug that new line was. Day 5, part 1. Kind of a sad thing to get stuck on. Let's move on, though. Everyone will starve if you only plant such a small number of seeds. Rereading the answer, it looks like the seeds line actually describes ranges of seed numbers. Okay, so the almanac itself, we still understand. The values on the initial seeds line come in pairs. Within each pair, the first is the start and the second is the length. Uh-oh. Is it possible that this is going to be so many numbers I have to do something smarter than just chasing the map all the way through? Probably not. I bet. I mean, I don't know. We'll see how many numbers there are to deal with. Let's go look at my input again. My real input, please. Okay, they come in pairs. The first is the start, the second is the length. 187 million, huh? That's pretty long. Yeah. I mean, computers can do a billion things, and we have an efficient-ish algorithm. Maybe. But I suspect what we should actually do is not iterate over all of the seeds we're given. Because each input seed, like, there's going to be a range of inputs of some size that all map into, like, another range, right? And each number in that input range, the only one you have to look at is the first one, right? If you collapse the mapping range, the almanac's indexes into a single step lookup from beginning to end, then you just have to figure out where you have to partition the input ranges based on which section of the almanac they map through, and then just for each of those input ranges just look at the first one, right? Otherwise we'd be doing hundreds of millions of times too much work, probably, or I mean something in that order. Which means that I think the first thing for part 2 to do is to find a way to collapse or condense or whatever you want to call it, the index. How do you do that? You... For... I guess for each... You have to consider two mappings at the same time and combine them into one, obviously, right? You have to compose them. Yes, compose is a good function. And I guess you want to look at, like... Let's put some code on the screen so you can at least have fun while we think. You want... When a range A, let's say, in the first mapping maps to a new range B, which it will, in the second thing, you have to look through the second mapping's ranges to see where that new range B would be partitioned up. Each subrange, right? So you look for the mapping. Oh, this sucks. You find the mapping that in the second almanac or index is pointed to by the range from the first index, and you see how far it goes, and then that is one new range. Yeah, so maybe what we want is like a function that takes two mappings and outputs like, yes, a mapping would be nice, but just a list of ranges would be fine. And then we already have a way to collapse that down into a mapping, right? It's in collate, right? Collate combines pages. We don't really need that anymore because we're just going to have one index or one page. But it's just, I mean, it's mapping, right? Kind of this. We have this from range function. Okay, so I guess let's just write compose. I say just. It's like the hardest thing we're going to do tonight, probably. And here I am 2 hours in or something. But what we need is compose, which takes a mapping and a mapping and, like, I guess I might as well return a mapping, right? I said a list of ranges would be fine, and that's true, but it's not much harder to produce a mapping because we just post-process it with, like, from list, basically. Okay. Compose F and G is what exactly? So it map.from list from range ranges. Ranges is undefined. From range of R as range. Yeah, that's not the range function that actually is in scope for me. Thank you very much. What is a source dest size? It's here. Type checks? Yes, but I haven't used F or G. Sure. So it seems as though we need, first of all, to iterate over the entries in F, right? And what is a mapping? It has ranges, doesn't it? So I can just look at the elements. I don't need the keys. Yes. Range cert dest len from elements F. Right? Actually, I'm going to go take a break before I start this. I'll have lost my train of thought when I get back, so enjoy that. Okay, so I was gone for a while, and I have lost my train of thought, as I promised. I also, like, knocked my glass of water all over my desk and poured it all over the floor, so I had some cleanup to do, and I'm, like, all out of sorts. But I thought a little bit more about how I want to do this, and I think I don't want to do compose yet. The function that I want first is I was thinking about how compose is going to work. And it has this problem where, like, it's kind of awkward to handle, like, when F has a mapping but G doesn't, and so F maps implicitly, like, into G's implicit mapping of, like, O just passed through. And likewise, oh, what if G has a mapping but F doesn't? Then F has to map, like, implicitly to that part of G, but then the real, like, translation in G still has to happen, right? And so it would be nice if we made an explicit version of the page numbering where there was no gap. Everything was covered, right? It's a little awkward. Like, we can start the bottom at 0. The top, I guess we can just do max bound of int, right? Like, yeah, there you go. And let me just make sure we can put that into an int map. I can't imagine why not. Sure, that's allowed. And if I try adding 1, what exactly happens? It wraps around? Yeah, okay. So if we insert, like, an artificial mapping at the end of each map, an artificial range at the end of each mapping that says, oh, you know, the range from the end of what this thing actually maps to infinity is just the identity, then that would be kind of nice, right? Takes an index? No. It takes a mapping. So I kind of want to explicit of implicit is exec writer of go 0, I think. So we're gonna need import control monad trans writer. We want exec writer and tell. And this is just like a weird, I'm just writing a complicated concat map basically, but I think it makes more sense in the cast as a writer basically. Import control, hang on. Where's when? Is that in? Okay, it must be in control monad then. Yes. Where go of n is going to be a function that produces, oh, I guess it's going to be m dot im dot from list am I going to be doing this again? From range? I guess. I'm getting the idea that from range really needs to be a top level function. It seems like I need it everywhere. Range to mapping is this. And this IAM from list maybe should be included in that as well, and like this map of from range or whatever. I think we'll just do range to mapping. So we're gonna do a recursive function in the writer monad, where each number we output one or possibly two ranges, or I don't know, yeah. Or 0 if we're done, I guess. No, at the end when we're done, we're going to... We're going to output one range, which is like, okay, and then from here to infinity. But... How do... So I'm imagining... When we get to 0, what am I? I'm going to look up this range, the range that covers 0. Right? Am I using lookup LT here? I mean, I must be, right? Okay, I guess I should actually... carry around the implicit map in my recursion and deconstruct it as I go. I think. So that any ranges... But then... How will I know... If I remove, how will I know whether I'm looking at something before the first entry? In which case, output something from 0 to it. Well, because n is only going to be 0 in that case. So when Go sees an n, it should never output a range that's before n. It should definitely output a range that starts with n, and then decide what to do. Decide how far that range goes, and if it needs more ranges after that or something. So... I think that makes sense. Case IAM.lookup less than or equal to n in implicit of. If we get a nothing, what do we... That means... There's nothing in the implicit map left of here. So we've handled everything up. We assume upon entry into Go that we've handled everything left of n, everything before n. And if there are no entries less than this, then we need to see whether there's an entry greater than this and emit a range for it, right? So it's kind of gross, but I think I want to write case im.lookup greater than and implicit of. Now, if there's nothing there either, then this is where we emit our... Can I actually make this always output exactly 1 and then I don't need this writer stuff? Let's see. Let's just return, in this case, a range from n to max bound. No. N to n of size max bound minus n plus 1? Yeah, that makes sense. If there is something greater than our value, but nothing less than it, then we are in a gap not covered by the implicit map. So if we see just a... Don't care about the key. Range low, high, no, from to len, then we produce a new range from n to n, saying just implicitly fall through, whose length is from minus n, not minus 1 or plus 1 or something, because if we're looking at a space 1 before the next mapping starts, we need to output a size 1 thing, and the difference of from minus n will also be 1. So I think that's right. So it's this, cons 2, go from implicit unchanged, right? I think I can forget all this writer stuff. Then, if there was a thing below us that we should be looking at, how would this ever happen? Only if we're looking at 0, right? I think. Well, no. We're less than or equal, so if we're starting a new range, that's fine too. And here I think I do need from and to, because I need to actually output this range. But in this case, all I really need is 2, isn't it? Because I have a complete range. And I just want to output that range, cons to go Something less than or equal to us. Yeah, I think so. Go of 2 plus 1 and m dot delete, I think it's called. im dot delete. Probably it's key and then value. Oh, so I do need the from. From implicit, right? Nope, hang on. This is not 2. It's from. We're calling these source and dest. Okay, well, we'll call them from and to today. Len. Len is what I need, though. From plus len. That makes sense. Okay, what do I call something with too few arguments or something? No, not. So what is the type of... This doesn't look like a complete type error, is it? No, there's a bunch more stuff here. Mapping to mapping. Where am I? Lost in the windows. So I have a mapping as input. Which is an int map of range. Oh, this actually should be composed with go0, shouldn't it? Not applied to go0. Range and list of range. So explicit is returning a list. Sure, I guess since this function is now returning lists, we should say pure of that. And now there's the same annoying thing where from range to mapping is this pair. I am from list, map range to mapping. That makes sense. We're returning, okay. What is the type of go? Go should be of type int mapping list of range, I think. Aha. Well, wait. What is range to mapping? This takes a range and produces a pair. This is why you're advised to put type signatures on your top level functions at least, is that you saw GHC said there were like 5 type errors in this function because it didn't know what I meant to do, and it guessed one thing and then said, okay, well, here's how you fucked up doing that thing. Once I put this here saying what I meant to do, it's like, oh, you made one mistake. It's over there. Often local functions are small enough or simple enough or self-contained enough that it's not worth the trouble to give them a type. But in this case, since I was starting to get lost in the types, I gave it a type, and now GHC can help me more. You're saying R cons to go. Yeah, I mean, that makes sense. Sort of, but... You're saying for some reason you expected R. Oh, yep. That's the problem. The range is here. Okay, so I don't need any of this control monad or writer shit. Oh, ranged mapping doesn't have a type? That's true. It's not really a mapping, right? It produces the arguments for it. Maybe what I need is ranges to mapping. Is map, no, it's im dot from list map go where go of this is that. So now I can just say ranges to mapping over that and ranges to mapping here. Okay. So what I would like to know is, does this work at all? What is explicit of an empty map? Range from 0, uh-oh. I've already made the size wrong. Oh, yeah, I guess, sure. But if I had a non-empty map, would that make any difference? Explicit of im.singleton 0 and then range 0 to 5 size 5. This looks better. So from 0 to 5, well, you map 0 to 5 at a size of 5 as well. So that's 0, 1, 2, 3, and 4 are mapped to 5 higher than they would be. And then starting at 5, you map just straight to 5, which something doesn't seem right. I guess it's fine. Two different numbers in the source can map the same thing in the destination. They kind of have to if there's any remappings and it's not a complete remapping. And then the size is like very large. So I'm just going to say that this is successful. Because, well, okay, I guess I should test real quick. Suppose that we didn't start at range 0, but we started at range like at 1? Uh-oh. Never makes any progress. Okay, cool. That's good to know. Oh, well, that's because this isn't... I have to edit this in both places, like that. There. That was an invalid mapping I provided. So 0 maps 0 to 0 for a width of 1. And then 1 maps from 1 to 5, a size of 5. That all looks great. And then there's a thing at the end, which, whatever. Now we've made an explicit... Every time we look something up in this map, we'll find a mapping that covers the thing we looked up. We'll never find, oh, there's no mapping here, so just fall through. Which, how did I even do that in part 1? I don't remember. Location was this function. Where the heck is location? Here it is. Oh, it was calling translate, that's right. Which was saying, oh, look up the only entry that could possibly refer to this one and use it if it applies, but otherwise don't use it. And so now, like, we're not going to have that don't use it case. But, I mean, we're not having translate at all, right? We're doing bulk operations now. So now, compose is a little bit nicer when every range is explicit, I think. Okay. Well, the good news is this is a new, we can just say ranges to mapping here. Now, I really thought I was just going to be able to do on this. It seems like I can't just write... I can't just write a list comprehension and have that be right, can I? Maybe. But I think a recursive function is going to be more necessary here. Because once again, I'm going to have to like find a little range and then map it through both things. And then whenever that range stops, I have to pick up again and call ranges again. So... say range is starting from 0, let's say. And do I need... I don't need to delete anything from the input here. Because... tracking n will just be perfectly enough to tell me which part of both things I'm in. Yeah, I think that's true. Now, if n is ever negative, I'm gonna, like, cry a little bit, but I think that's fine. Because I'll have consumed the last range, and it'll say, okay, go up by 1, and then keep looking for stuff to do. And I'll say if n is equal to min bound, then there's no more ranges, I guess. Or maybe it would be a little bit better to say if the, like, the from plus the len is equal to mac from plus len minus 1, from plus len plus 1. if the place where you would look for the next one is too big, which would be from plus len. Yeah, I guess just from plus len is negative, then you should probably stop. And we should just be able to like say let range circ dest len equal. What are the order of arguments to the map lookup operator? Map first, then key. So it's... So the order of this composition, by the way, is going to be F and then G, I guess? I guess it makes sense for it to be G, then F? In like the same way that when you compose two functions, you call G and then you call F. I do have to like have it straight. The decision doesn't matter, but I have to like get it right. I'd like to just fold our compose over all of the things, I think. Well, except I can't because I put them in a map keyed by string, and so they're in some random fucking order now. So I think I'll be doing it where like the leftmost, the F is like having composed all of the first n maps, and G is like the next map. So we want to look up through F first. So int map.lookup there. This is the exclamation point is because it's a lookup that will throw an error if it fails. It won't do anything nice and pretty. But this isn't even the function I want, of course. I want lookup LE. Which takes the key first. N of F. And we'll case match on that. I mean, we know it's going to hit. So if it doesn't, we better print an error here. Show n in show f, I guess. Doesn't have to be beautiful. Just a key, which I don't care about, and then I don't know if I need this R. Let's just, I'm going to put it in case I forget and put it out here otherwise. That's a range. Wait. I wrote this, but this doesn't make sense. It needs to be inside the case match. I was thinking, oh, I'll just look it up and assert that it's there, but it would sort of be better to at least print an error message that says what went wrong. we found a range in F. And let's let some variables. Let's let start be source. And now we know this one actually covers n because we've made sure the maps are covering. There's no gaps in them. And this is the largest one smaller than n or equal. So it's source plus wait, why do I care about what the start is exactly? I want like the offset, I guess, be n minus source. So that's how far off we are from where the range expects us to be. So then our start is kind of destination plus offset. Dest prime, and len prime is len minus offset. So we're building a range that is smaller by the amount of the offset. Now, I don't know that I can actually use this range for anything. It just seemed like these would be nice things to know, but maybe they aren't. No, I mean, they're sort of good. Let's then look up in G the first entry that is, or the largest entry that is no larger than dest prime, right? Case IAM lookup LE dest prime G of basically this, right? So that little quote will help us distinguish which of these errors is printing at least. Although I think it'll tell me which line, maybe? I'm not sure. Just of, again, we don't care about the key. Boy, I think it would have been faster to just have the computer run 100 million of these by now. But this is like the correct approach. S, I guess, would be the letter after R. Range, oh god, I can't call them source dest and whatever. Oh no. SDL, oh no, it doesn't even work. Fdest, flen. Odest, olen. For original or offset based. Nightmarish. Range source prime, dest prime, len prime, right? Here we have to do something. We now have two ranges, and we have to figure out well, what offset to use, sort of, right? And how long to go, like how much space to assign here. So we want to figure out, again, the offset inside the G range, don't we? I think so that we know what space we're mapping into and how much is left. Offset prime is, we were looking up ODST minus source prime. So that's how much of the range we already consumed. ODST prime is something's wrong. It's DST prime plus offset prime. Len prime is len prime minus offset prime. That makes sense, I think, that I didn't write let. In. I don't know if we're ready to write in yet. Cause now I know I think I know what I want to write as the start of my range. I always knew that before I even started. I wanted a range that starts at n. And I think its length should be the minimum of O-len and O-len prime, right? And the destination should be O-dest prime. So, I don't know. I think this kind of makes sense. I think we can say it's a range where the source, the beginning of the range is n. That's what we were trying to find, a range that started there, and we found one. Its destination, its destination is O-dest prime. Its length is O-len prime, right? And then we cons that to ranges of n plus O-len prime. Now, this doesn't handle the boundary condition of wraparound, integer wraparound. But I suspect we'll have more serious problems, like it doesn't type check at all. How bad is it? Only 2 type errors, okay. Oh, something doesn't look right. Character? What? Oh. It does type check. I just forgot some dollar signs. Defined but not used are. Yeah, okay, that's fine with me. And this one too. I just thought I might need it, you know? Defined but not used olen. Uh-oh. Oh, the length, right. New len, I guess, is like shortest is min of olen prime. Why did I write shorted on twice of both of those? I don't know. So we've omitted a segment that is as short as the shortest of them. But it still should be the case that when we next... Oh, do I need to like add one or something? No, because the shortest of them should be at least one, right? It can't be 0? I think that's true. So, what if we tried compose explicit singleton of, you know, at 1, we map 1 to 10, 1 to 11. We add 10 to it, and we do that 10 times. And we want to compose that with explicit of singleton, something that happens at 5, let's say. Singleton 5, range 5, 15, 10. Parse error. Too many closed parents? I am dot singleton. Oh, I haven't. Okay, fine. Error. Okay, that's actually really exciting news. Because it made it all the way to negative a billion, zillion, trillion, gazillion, right? So we actually just need, like, to throw this in, where we say, like, neg n equals nothing. Otherwise equals. Does this actually have to be over here? It's not allowed to... okay. Oh, gosh. The fact that there's, like, no single valid indentation for Haskell code, like, but there is only one that means what you meant, is a bit annoying. So the Haskell tooling will, like, guess or offer you multiple choices, but it can't, like, just indent it correctly. How do you write, like... Is there not a function like that? N less than 0? I don't know. And so we get a new mapping. 0 maps to 0, but only for a distance of 1. Then 1... Uh-oh. Really? 1 maps to 21? Is that right? Oh, yeah, that is right. Because we added 10 to 1, yielding 11 here. And then here, we're mapping from 5 to 15, adding 10. So yeah, we should be adding 20 there for 4. And then starting at 5, we do something different. Because why? Because once we're at 5, we're in the range for this, but after we add 10, we're no longer in the range for this? That sounds right. So we should just be adding 10, 5 to 15 for size 6. This looks amazing. And then at the end, we say, oh, you know, if you were 15 or more, just map to yourself. This looks perfect. It looks like it worked. I'm so excited I'm going to git commit this before I fuck it up. Okay, great. Now, that's not to say it's necessarily perfect, but it looks like it did what I wanted. And we don't write tests in this house. So we're going to assume it's correct because it worked on 1 input. I mean, Haskell has great support for generative testing. But I'm like, I don't know. It is fun to do that, but I don't really know how. I remember once years ago when I had just read about generative testing, and I tried it once at my job. I was using Clojure at the time, and it was like a fun and challenging experience writing tests, and it caught a bunch of edge cases that I wouldn't have thought of. Except I did think about it because I told the system, hey, here's some properties my system should have. And then it said, well, actually it doesn't have these properties. And I was like, oh, you're right. Wow. Amazing. Because it found inputs that I wouldn't have thought to test to verify the properties that I did think were important. Anyways, we have compose now. And I believe... what do I do with that? I think I need to turn the list of pairs of seeds that comes in into its own mapping, in a way? Does that make sense? Not quite. But, okay. What, by the way, is there a good Haskell function for splitting lists into pairs and just assuming everything will be okay? I mean, sure, it's easy enough to write one. Pairs, nothing is empty. Pairs of x, y, x's is x, y, x's. I know, we're not using pairs. What? How can there be something wrong in this? This was a correct function, wasn't it? How could you infer the type of pairs? Oh, yep. Well, no, hang on. Is there something wrong here? It's such an easy function. How could I be wrong? Oh, pairs of x's. There we go. So that's a function that'll pair up the seeds, which is nice, I guess. So I think we're about ready to write part 2. We're just going to kind of replicate a little bit of the work from compose in traversing the seed pairs, basically. Of almanac, seeds, and index is minimum of go of 0 and pairs x's, pairs seeds, I think. Minimum go 0 pairs. So starting at the beginning. Well, wait, why am I starting at 0? I need a number. Maybe? No, I can probably just use pairs of seeds. Go of, and this like should just be, I don't know what kind of function this is. It's too complicated. Go of empty is empty. I think that's gonna be right. If we've processed all the seeds, then we can go. Go of, now the y in the problem statement is the length, correct? Yes. Go of start len equals these case things could have been way better if I had just used the unsafe lookup. No, but I needed to look up less than or equal to, and that always... Okay. And here, I also need lookup less than or equal to, right? Case im dot lookup less than or equal to start in M. M is fold. Oh, I got to get this right. Oh, the problem is I can't. Because they're all in a stupid order. Right. I gotta get out of here, man. I'm going crazy. I know this isn't that hard a problem, but I don't know. It's also not easy. I need to do I need to look in the index, find the map for seeds, and then combine that with whatever it points to and continue, right? Collapse seed? No, collapse index seed, like that. Collapse of F, and the index is a map from ingredient to page. A page has a from, a to, and a mapping. So page from to mapping is, I've already got the from. Look up in index 2. If there's nothing there, then it's just mapping. If instead we have, okay, is this is a page that I'm getting, is that right? The index? Forgot already, yes. Page 2 prime. Oh, let's call this F, shall we? G. Then we want to collapse page from 2 prime of compose F with G, I think. Yeah, I haven't finished writing this, so sure. Where? It is pretty hard to read to understand what I'm getting from that one. I only get a couple of lines. Oh, look up 2 in the index, not the other way around. Just one error left. Returns a list of something, or is it expected? No, it expected a list of something. I was actually returning... No, not returning. It's mad about the argument type that Go has. Still upset, but like differently now. It expects a list of pairs all of a sudden. Yep, that's another mistake I made. There we go. Let's get rid of that. and now... Oh, it was supposed to be like that. It needs parentheses. Now we only have warnings. Great. So we're looking in the collapsed map of all going straight from soil to location. Error. Show. I'm beyond making pretty error messages right now. Oh, we usually put the of on that line, don't we? There we go. Just of, what would we get here? We would get a range. Source, dest, and len. Len prime? Don't want to shadow this line, of course. Let's let offset equal start minus source. Is that right? Yeah. So then we know dest prime is dest plus offset. I do need a way to terminate this loop at some point. Oh, it'll terminate when the list of seeds passed to go becomes empty, right? Yeah, I guess I have to just figure out now whether I've finished handling the seed, the first seed in Go, because it ran out of length. Or whether I ran out of range in the map. Well, I kind of have to compute the new length. Yeah, okay, I guess that's not so bad. Shortest is... min of len and len prime minus offset, right? If that length is equal to len, then we can throw away the previous seed. And otherwise, we should increase its start and decrease its length. Either way, we should now emit start. Because, no, not start. Dest prime. Cons to if. That goes pretty far left. If len is the shortest, then I don't know, I guess there's fine. Then we're done with this seed in Go, and we can say Go X's. Else, Go start minus start plus shortest, len minus shortest, I think. What is this error? What type do you think Go has? I think Go has type list of pair of int and int to list of int, right? Equation for part 2. Oh. I didn't update this. And then it's also mad that when I call lookup, I should ignore a key. Forgot a comma? Go of this cons to x's, please. Okay, the type checks. Any bets? My optimism is not high. Error. Yeah. Can't find, so it couldn't compose the whole thing, huh? Or it, yeah, how many digits is that? 9? Boy, I mean, I agree with you. I can't find that number in there either. Nine digits. The first entry here is 10 digits. But this is supposed to be explicit. It's supposed to cover everything. Did I forget to call explicit on all of them? I think I did, but I'm like lost trying to find where I even collapsed stuff. Yes, I did. Okay. Sure. So it's easy enough to just write an explicit here to, like, before I slurp up G, I can make it explicit. It's a little bit awkward. Like, I think explicit should be the identity if you apply it multiple times. But it would be sort of nice to only do it once, wouldn't it? Collapse start, I guess, where page from to F is and start is page from to explicit F. Okay, I mean, that seems like a plausible fix. It's a number. It should be lower than this one. That's the left one. That's our sanity check, right? So left one's 9 digits, starts with 1. Right one's 8 digits, starts with 5. It's possible. Let's see. Holy cow, it's the right answer. Well, we can't say that as soon as it compiles it works, because I had a lot of non-working versions that printed errors throughout the night. But we did it. We soldiered through, we persevered, we wrote a steaming pile of garbage. But it's a steaming pile of garbage that works very well for inputs much larger than the ones we were given here, right? Like, if I look at stack work, where would this even go? I don't understand how stack works. But somehow, somewhere in here, install? Bin? And then, yeah. So that's actually an executable, right? Yeah. So if I just run this with time, yeah, it runs the whole thing in 1/100th of a second. And there's no way it was going to do things that fast if we had processed every single seed from all the ranges in the input, right? You know, suppose we had been 100 million times slower. Would that have been a problem? I don't know, maybe. 100 times slower would have been a second. 1,000,000 seconds is a really fucking long time. Right? Like, yeah, there's way more than way less than 1,000,000 seconds in a day. So I think we did have to do it this way, which is good. Okay, I don't know, man. Oh, I staged that hunk without even reading it. Is there actually anything weird in here? Split it, please. There's really just one huge hunk. Oh, is this it? Is it just part 2? Did I not use anything anywhere else? Git diff? Oh. I mean, honestly, not bad. Oh, no, because I also wrote the compose function, right? Yeah. Okay, but I don't know. It could have been worse. All right, I'm getting out of here. I can't believe you guys made it to the end. Congratulations. See you tomorrow. That's not usually how I end the video. I usually say, hope you guys enjoyed. Thanks for watching, and I'll see you next time.